In this video, I'm going to take you through the step-by-step solution to West African Senior School Certificate Examination 2022 Physics Practical, Alternative B, Question 3. This question is under electricity. Now you are provided with a resistance box. This is a decade resistance box with 7 dials. This dial measures up to 10 ohms. 1, 2, 3, 4, 5, 6, 7, up to 10 ohms. This dial also measures in tens. So when I move the dial once, it's 10, it's 20, 30. It goes up to 100 ohms. And this dial measures in hundreds up to 1000. That's 100, 200, 300, 400, up to 1000 ohms. For this experiment, we need up to 10 ohms, so we will use this dial. A key. A 2 ohms resistor. A voltmeter. A battery. We have 2 cells. This is the positive terminal of the cell, and this is the negative terminal. We are going to put the cell in a cell holder. This is the positive terminal of the cell holder, and this is the negative terminal. So we put the cell in the cell holder in such a way that the positive terminal of the cell goes to the positive terminal of the cell holder and negative to negative. So we fix another cell, positive to positive, negative to negative. And we join the negative terminal of one cell holder to the positive terminal of the other cell holder to form a battery of 2 cells in series. This battery consists of 2 cells of 1.5 volts each. So the total EMF is 3.0. We can alternatively use this power supply. We turn off the alternating current because we need a direct current for this experiment, and we set the EMF to 3.0 volts, just like this one. So we can use this power supply in place of this battery. This is the positive terminal and this is the negative terminal, just like this. I prefer using the power supply because it provides steady current throughout the experiment. Some connecting wires, and other necessary apparatus. We are going to set up the circuit as shown in this diagram. This represents the power supply. This is the key, and this represents the resistance box, and this is the 2 ohms resistor and this is the voltmeter. So we start from the negative terminal of the power supply to the key. And from the other end of the key to the resistance box. And from the other end of the resistance box to the 2 ohms resistor. And from the 2 ohms resistor to the positive terminal of the power supply. We are going to connect the voltmeter in parallel to the 2 ohms resistor. So we connect these terminals to the 2 ohms resistor. So we close the key and set the resistance box to 8 ohms. And with the key closed, we record the reading on the voltmeter. So we have 0.61. Then we change the resistance box to 6 ohms and we have 0.76 volts. We change it to 5 ohms and we have 0.86. Change to 4 and we have 0.99. Change to 2 and we have 1.46. And for 1 we have 1.90 volts. So we have the resistance in ohms and voltage in volts. The next thing is to evaluate V inverse in each case. So we have V inverse and the unit will be per volts. So we take this value, 1 divided by 0.61 is 1.64. And 1 divided by 0.76 is 1.32. 1 divided by 0.86 is 1.16. 1 over 0.99 is 1.01. And 1 divided by 1.46 is 0.68. 1 divided by 1.90 is 0.53. We leave all these values in 2 decimal places. Check the units very well. The resistance is in ohms, voltage is in volts, and V inverse is in per volts. So we tabulate the results. We are going to plot a graph with V inverse on the vertical axis and R on the horizontal axis, starting both axes from the origin. So we need the values of V inverse. it will be difficult to plot 1.64 on the graph, so we convert it to standard form by moving the point 1, 2 to the right. So we have 164 times 10 exponent negative 2, and the unit is per volts. That's standard form. So we move this point to 1, 2, and we have 132. This one will be 116. This is 101. This will be 68, and this is 53. All times 10 exponent negative 2 per volts. And we also need the values of R. For the values of R, they are whole numbers, so we can easily plot them, so we don't convert them to standard form. So for the values of R, we have 8, 6, 5, 4, 2, and 1. So we are going to plot these values on the graph. So we draw our vertical and horizontal axis. So we are going to plot a graph of V inverse times 10 exponent negative 2 per volt on the vertical axis, and then R ohms on the horizontal axis. We have to choose a scale. We are going to choose a scale of 2 centimeters to 20 times 10 exponent negative 2 volts on the V inverse axis. So we start from 0, 20, 40, 60, 80, and so on. And on the R axis, we choose a scale of 2 centimeters to 1 ohm. So from 0, we have 1, 2, 3, 4, 5, and so on. On the vertical axis, one big box is 20. So 20 divided by 10 is 2. So each small box is 2 on the vertical axis. And on the horizontal axis, one big box is 1. When we divide 1 by 10, each small box on the horizontal axis is going to be 0.1. So this should guide us to plot the graph. The first point, we have 164 on the vertical axis. This is 160. One box is 2, so 162, 164. We count 2 more boxes. And we have 8 on R axis. So 8 here and 164 will be here. The next one is we have 6 on the R axis and 132 on V inverse axis. This is 130, in between 120 and 140. So for 132, we move 1 more box and we have the point here. The next one, 5 on R axis and 116. This is 100 on the vertical axis. The middle is 110. So 116 means we have to move 3 more boxes up for the 6. The next one is 4 and 101. So this is 4, this is 100. When we move 1 box, it will be 102. So we put it in the middle of the next box here. The next one is 2 and 68. This is 2. This is 60. We count 4 more boxes since 1 box is 2. So we have the point here. The last one is 1 on the R axis and 53. on the vertical axis. So this is 50. The next box will be 52, and we put it in the middle of the next box like this. So we draw our line of best fit. We are going to determine the slope of the graph. So we draw a horizontal and a vertical line. Name here A, B, and C. The slope is given by change in BC divided by change in AB. For change in BC, we have 150 minus 80. Remember, times 10 exponent negative 2 per volts. And for change in AB, we have 7 over here minus this is 2.8. The unit over here is ohms. So 150 minus 80 will give us 70. Remember, times 10 exponent negative 2 per volts. 7 minus 2.8 is 4.2 ohms. And 70 times 10 exponent negative 2 is 0.7 per volts divided by the 4.2 ohms. 0.7 divided by 4.2 will give us 0.17 to 2 decimal places, and the numerator we have per volts and the denominator is ohms, so the reciprocal will be per ohms. So this is our slope. We are going to determine the intercept C on the vertical axis. So this line of best fit cuts the vertical axis over here. This is 20, this is 30, 32, 34, 35. So the intercept is 35. Remember, times 10 exponent negative 2 per volts. And 35 times 10 exponent negative 2 is 0.35 per volts. So this is the intercept on the vertical axis. We are going to divide the intercept by the slope. The intercept is 0.35 per volts and the slope is 0.17 per volt per ohms. So V inverse can cancel out, and 0.35 divided by 0.17 is 2.06. Ohms exponent negative 1 is at the denominator, so the reciprocal will be ohms.